try. No internet? Why does the internet? There's the line. Is there any line? You have to find the line.
Yeah, it's already under the ground.
It's not blinking here. Do you have any computer that you can download? Okay, today's topic is a very important topic because it's going to be covered in the final exam. So, the topics, these two topics must be included. So at the end of the class, I will tell you the topics that will be covered in the final two. So part of it is this one. Okay, so you have tried to understand and try to simulate to look at the things that we are going to learn today. So two things, yeah. The first one is the array, and the second one is the stack pointer. Okay, stack pointer dalam bahasa Melayu dipanggil penunjuk tindanan. If you go back to the first chapter that we have, for example here, if you go back to the first chapter last time, you can remember that we have the data register, we have address register, we have program counter, we have status register. The last topic that going to be touched today is this stack pointer. Stack pointer dalam bahasa Melayu dipanggil penunjuk tindanan. Pointer means tunjuk, stack is tindanan. Okay, stacking. Alright, this is stack pointer, which is refers to A7, whereas A0 to A6 is address register, and the last A7 is dedicated for the stack pointer. Okay, this is very important. Okay, the function is to store a pointer to a group of data known as the stack A7, which is A7, which is the USB and SSD. So I'm going to touch this after the first array. Okay, so we go to the array first. Okay, the first few slides is actually about declaring syntax. Okay, in this first slide is the EQU is equal to equate. This is like declaration. When you do C++, you have to declare. You are declaring your names to the integer type, variable type. That's all the declaring session. So EQU is another declaration. You look at over here, for example, this is the name, equate, this is the value. So you are going to use this name later anytime. Once you already declare it, you can declare anything in your code. Okay, so this is only EQU. So this can be used in your final projects, basically. EQ means equate or equal. So this is the example just now that you just can read the one. And this is for define constant dc dot something, dc dot byte, dc dot w. We have done so far from the starting of the semester or the micro C class, micro P class. Define constant is define constant, dc dot byte something blah blah blah. So this is the thing. Example. Next one, define storage, ds dot something. I do not touch this one in the beginning, but this is in this chapter and I do not put it in the first text. So ds is another syntax, define storage. So there are three syntax just now. The first one is EQU, equate. Equate. The second one is define constant. This is very familiar. And the last one is define storage. Is this one. Storage is just to empty the slots of the memory location. So okay, that's one. So these three things is not related to the array, but is the syntax that you may need to know when you are doing your project. Okay, let's move on to the array diagram. So what is array? What is array? Array is very basic stuff where you can put the informations by row and column. Very simple. It's an array. Right? Like for your Excel, it's an array of data. So you can define your data through the array. Over here, there are two types of array. The first one is one-dimensional array. The other one, they call it two-dimensional array. So the difference is very simple. One-dimensional array is only have a line only, one row only, single row. Okay. It is also called a list. The names of the array, which is only one-dimensional, is also called a list. List ialah satu-dimensional array. Okay, the next one, they call it two-dimensional array, which is also known as matrix. Matrix you learn from Form 4, if I'm not mistaken. In secondary school in Malaysia, you learn in Form 4 matrix. Okay, matrix 2 times 2, 2 times 4. So for example, if you look over here, this is the array for the two-dimensional. You have 3 times 3 array. Whereas this one is only 5 times 1 row. So cards, for example, cards is a one array over here. Suits is another one array here. To create an array, you are using the define constant syntax. Look over here. So this is a command. When you are doing the array for the cards, you are using this command. And this is the contents of the array for cards. Another example is the suits. This is just a name. You can put whatever names that you want to have. This is just a name. Alright? So cards define constant of byte. This is the one. Suits define constant of byte. This is the one. So means that you can see the contents of the array to the particular locations of the memory. Before define constant, you must have your origin over here, biasa here. Right? You have to have your origin where you want to put your memory area. Okay? So another syntax that can be used is define storage. So just now we are talking about define storage and define constant. This is another method to do another array, which is the same cards. Cards define storage byte 5 means it's going to reserve 5 areas of byte size for the cards array. And then 1 line. Because you can see that it does not like this. This is considered 1 line. Whereas a two-dimensional, you only have 1 names over here. You are going to define constant dot byte, then you have the first row, then the next row, and the third row with only 1 name over here. This is called two-dimensional array. So two-dimensional array, this is 3 times 3. Okay? Row and column is 3 times 3. So it's up to you, you want to do how many arrays that you want. So you have the list over here, you have the matrix over here. They call it the names list and matrix. List is one-dimensional array, matrix ialah two-dimensional array. That is the names over here. Okay. Cuts and suits are 5 byte one-dimensional array. Each array represents one row of 5 values. One row, 5 values. Okay, this is declaration. It's up to you. You want to declare like 10 components, doesn't matter. This is example only. To specific element means any values over here, they call it elements. So 3 terms over here, list, matrix, and elements. Elements is the contents each of the array. Okay? To specify element access will depends on the positions in the array, which called the index. Another terms. So just now is list, then matrix. The third one is elements, and the last one is index. What does it mean index? Index means, for example here, for 5 element array, the index has a range of 0 to 4. That's the index. Okay? So the element, this is the first element, second element, third element, fourth element, and fifth element. But the index is the range from 0 to 4. The range, we have to start from 0. You cannot start from 1. The range must be start from 0. So for example here, this is 0 to 5, 0 to 4 index. So there are 4 terms there. You have to clearly understand these terms. List, matrix, elements, and index. So that is the introductions of the array. Next. So you can download the copy just now. Do you have all things in your PC? You can look at the array code first. That is the example of the array codes, which should be the same one like you downloaded from the ULED. Okay? So look at the code first, try to figure out first. So where is the place that you declare your array? So from here, where's your array? You can see that basically your array is over here. This is your array. This is just your origin. You want to put something, define constant, this one, define constant long, this one, define constant long, but this is actually the number. So the rest of the program, what does it do? The rest of the program is basically you want to access any of the elements based on the numbers. Access means you can write and you can read from the array. Specific element based on the index. So means that you are going to use a command which is we have been using in the first few weeks last time, which is this pattern. A0, which is address register, comma, data register. So this is going to be used to access any elements from the array. Okay, let's try first. Run the code. Run the code. You have to be on the same page already. This array. So every page. Can you just copy from somebody? You can just copy, right? There's a file. You can copy from the PC. All this PC is actually hierarchical. So you can copy from your USB. can download from the ULEARN. Then copy from the file, copy the text file. That one doesn't virus because it's going to be replaced every time. Just say copy from somewhere. From the slides, this is the code for you to understand, and the code is a very simple approach because the code is going to change or write or read from the array any elements from the array accordingly to the index number. So look at one by one the line, try to understand it, what happens. Okay, ready? Ready?
Sama ada. Sama.
Okay, let's run this one. Let's run this one. If you look from your slides versus the code that I have, basically that you can remove the first few lines over here. If you look back at the code as the slides, again I'm telling you, there are few lines that you can remove. I don't have this all one. Actually, I remove this one, I remove this one, I remove this one, then I only use this one. So you can remove that one from your slides. So it is a bit different. The changes is only at the top of the code. The 3 lines I remove. Okay, now look at the code. What does it do? Okay, the first line. The first line I label it as my index. You remember that the index, it can be the range of the array. So right now I want to access index at number 3. Index define constant dot by 3. If I do not put any origin, by default, the memory will start at 0, 0, 0, 0, 0, 0. If I do not put any origin statement. So before the index, there's no origin like this. So means that I'm going to put the first value at the first memory location. Okay, now origin 1000, I start to put my array. This is my array type as using define constant dot byte 1, 2, 3, 4, 5. This is actually a number. So let's try to play around with the number, doesn't matter. So I can put any number in this array. Let's put this one. 8, 6, 3, 4, 5. Just the number. This is decimal number. So hexa is still the same, right? 8 hexa is still the same as decimal, as long as I do not put 10. 10 is already 8. So I just play around one number from 0 to 8. It's still a number. So array define constant the byte, this is all decimal, is also equivalent as hexa, so it doesn't matter. Origin 1100, then I have my code over here at 1100. So if you can compile now, you compile it and look at the memory over there. View memory. Starting from 0000000. So that is your memory, just now. My first 0000 is already 03. What does it mean? Because my first line just now is define constant dot byte 3. So means that by default there's no origin. By default the value will be placed at the first area in the memory location, which is 00. That one. Okay. So next one ialah, look at the value at 1100. So 1100. So that 1100, you have your machine code over here. That is your machine code. So where's the array? Your array is located at where? From the code, from the syntax. Where's your array? Your array is where? This is your machine code. So where's the array? At 0 is the index. At 1000. Origin 1000. This is your value of your array. So you look at the 1000 here, then you can see your array over there. 8, 6, 3, 4, 5. Betul? So this array range is 0 to 4. This is the first 0, 1, 2, 3, 4. The range of the array. So you want to play another array? You can put maybe 7 times 1 array, doesn't matter. So you close this one. You can play around another one. 7, 5. Let's try. This is your array for 7 elements. The range is from 0 to 6. Okay, the range is 0 to 6, the index. But the elements, how many elements? 1, 2, 3, 4, 5, 6, 7 elements. 6 elements, but the index is between 0 to 6. Okay? 6 the index, 0 to 6. The index is 0 here, index 1, index 2, 3, 4, 5, 6. Okay? Now try over here. Define constant of byte 3. This is the index that you want to search. Now look at your code. What does it do? What does it want to do? Your code say now is move address dot long, move the whole address hash array to A0. Hash array means it's referring to the label for this name. This array is over here. This is taking the address of the array. So what is the address starting from the array? 1000. So you are expecting 1000 to go to A0. Now look at it before we run it. Show for that. So the A0 is already 1000. Let's move next one. Move dot by index to D0. Index now is equivalent to 3. So 3 will be moved to D0. Move dot by 1C to D2. This is a number to D2. So you are going to play around this value. A0 is 1000 just now. D0 is 3. So it's 1000, 3 to D1. You are reading a value over here. You are reading this value, go to D1, and then you have this DT value, you are putting back to the array over here. Then this is to finalize, to confirm that that is the value. So now we are going to run it one by one. So look at carefully here. Execute. So the first line. So this one is all pre-processing done. Move address.log the array to A0. The address for array is just now you said is at 1000. So I move that one. So I run that one. Your A0 now changed to 1000. Still okay? Alright? So next move move dot by index to D0. Index is equivalent to 3. So means that your D0 should be 3. Now your D0 is changed to 3. Okay, next move. This is just a command for me to put a value, which is a move dot by a value to D2. This is a number to D2. So you're looking at D2 over here. This is must be changed to 1C. So I change it. Still okay? Now is the moment of assessing the array. Look carefully, where does it assess? So move dot by A0, which is equivalent to 1000. D0 is equivalent to 3. So what is the elements that is going to be put at D1 from the array? So that is the index number 3. So you are starting from here. The index number 3 value will be